Hello students, welcome to the video lecture session on power generation and economics. So this is a syllabus. Okay, today I am going to discuss the classification of the plants. Okay, classification of the plants based on the water flow regulation, water head, and type of load the plant has to supply. This further classified as, for an example, quantity of water available. I will take pen. Okay, quantity of water available classified as run-off river plants without pondage, run-off river plants with pondage, and third one is reservoir plants. Available head is classified as high head, medium head, and low head plants. Okay. Nature of load is classified as hydro base load, peak load, and pumped storage plants for peak load. Okay. So today I will explain what is base load, peak load. Okay, because to analyze this bit you should know the basic terms. Okay, what is base load and what is peak load, and what about pumped storage plants I will explain when I'm discussing this nature of load. Okay, let us begin with the first one. Runoff river plants without pondage. Here the name indicates, okay, the name indicates that what this is a plant where the water is not stored, means without storage of water the power generation has done. Okay, this type of plant does not store water, the plant uses water as it comes. Okay, as water it will be comes, for an example, the water it will be flow is there here, the water it will be taken off and it will be given to the turbine, and turbine generates the power, mechanical power, and coupled to the alternator, and alternator will be generates the electricity. Okay, as water it will be flows here. Okay, so in this such type of plants is called the without pondage. Okay, the plant can use water only as and when available, since these plants depends for the gen generating capacity primarily on the rate of flow of water. It depends upon the flow of water, depends upon the flow of water. And further next point is the capacity primarily on the rate of flow of water during rainy season. High flow rates may means some quantity of water to go as a waste, because the generating power plant is set up with a particular rating. So if more water it will becomes, we can't generate, because the water it will be goes waste itself, right? Because the generating capacity of plant is low. So if more water comes, we can't generate more power, it means. Okay, while during the low runoff periods, due to the low flow rates, the generating capacity may be impaired. Okay. Next power plant I'm going to discuss is the runoff river plants with pondage. Okay. The name here also it's indicate that the water stored in the small pondage. Okay. Pondage permits the store of water during the off-peak period and use this water during the peak period. Okay, off-peak period is means as earlier I have discussed, during the say day, during 2 p.m. to 5 p.m. there will be a load will be less on power station, right? Power plant, sorry. Okay, power generating plant during this 2 p.m. to 5 p.m. This is a term you can here using the off peak period. Yes, after 5 o'clock to say it is 9 p.m. there will be a there will be a large peak. There will be a large peak. Then that time this pondage type of power plant, it will be interconnected. Okay, so that to meet the load, depending on the size of the pondage provided, it may be possible to cope up hour to hour. Depending upon storage of water in pondage, we can cope up our requirement. Cope up with hour to hour means it depends upon if you want in between wherever in your load curve that we can utilize. Okay, here it is mentioned this type of plant can be used on part of load curve as required. Okay, within certain limitations, and is more useful than plant without storage or ponds. It will be a more effective, more advantage over the without pondage. And one more point here it is given, when providing the pondage, tail raise conditions should be such that floods do not rise the tail raise water level. Okay, so tail raise water level means the water where it will be comes after generation tail raise. Okay, so it should not be rise. If it will be raised means what it will be happens, if it will be rise is thus reducing the head on the plant and impairing its effectiveness. The height where it is there here, the head, what it will be happens, head, the tail raise water it will be raised means this it will be affects. Okay, okay, this type of plants is comparatively more reliable and its generating capacity is less dependent on available rate of flow of water, because the water is stored here. It is not depends upon the rate of flow of water, how much it will be flows, as compared to runoff river plants without pondage. Next plant is reservoir plants. Reservoir plant is nothing but the large catchment area. The dam is constructed across the river, and there will be a backside large catchment area. There, the ample of water is stored. Okay, such plant is called reservoir plant. Okay, the reservoir. I will take pen. Okay, reservoir plant is that which has reservoir of such a size as to permit carrying over a storage from wet season to the next dry season. What it means, the wet season, say it is in rainy seasons, we can store the water, and the next dry seasons we can utilize. Okay, means summer season we can utilize the stored water in reservoir. Water is stored behind the dam and is available to the plant with control as required. Okay, the water is stored in the reservoir. Depending upon the requirements, the water is used. The control as required means the plant with control means the water, how much it will be required for generation of electricity, it will be utilized. Such a plant has better capacity and can be used efficiently throughout the year, because the ample of water is stored, hence we can utilize throughout the year. Its firm capacity is increased and it can be used either as a base load plant or as peak load plant. Okay, now I will dictate what is the meaning of base load and peak load. Okay, it can also be used on any portion of the load curve. Okay, this load curve also I will explain. Okay. Majority of hydroelectric plants are of this type. Okay, now I will discuss here the base load, peak load, and what is load curve. Before explaining these things, let us have a glance over uh, the power plant. Varahi underground powerhouse. It is located under Udupi district, Vasangadi, okay, Karnataka. This is entrance. It is one tunnel is there inside. We have to walk nearly, I think, more than half kilometer or 1 kilometer. Then this entrance it will becomes very beautiful place to visit. Once we will see there. Okay, this is the inside plant view. Okay, here my discussion topic is the installed capacity. Related installed capacity I would like to explain here. The installed capacity of Orai hydel station is 230 megawatt. Okay, 230. How many units are there? 2 units are there. Each unit is generating 115 megawatt each. It is nothing but 100 into 2 means multiply with 2 units. What it will be happens? 230 megawatt. Okay, and let us have one more hydropower plant, Gersoppa. As you know, it is here only. It is located nearby. 1 hour we are going towards Shimoga. Okay, Gersoppa hydel power plant. Each how many units are there? 4 units. Each 60 megawatt. Total 240 megawatt. Okay. As earlier also I discussed, if you have number of units means according to our requirements we can turn it on to supply generate the power. Okay, and there will be a another one drawback also is there. If you have large number of units, say instead of 4 we can go for 8. Hmm? And generation is 240 itself. 4 units are there, 240. If I'm going for 8 unit for 240, okay, then what will be happens if the number of generating units are increased, there will be a installation and turbines, alternators, maintenance, lot of it will be involved. The compromising the between these 2 points. Okay, how many number of units is required, and how much generating power, these 2 points compromising, and you are installing, you are not going for the higher number to units. Okay, please note it this point also. Okay. Let us have a meaning what is load curve. Okay, load curve showing the variation of load on the power station with respect to time is known as load curve. Here graph. Okay, this is the time and this is the load in megawatt. The variation, if you are looking here, midnight to the midnight. Okay, the load on power station will be variable in nature. Okay, if I am plotting here one straight line, what it will be happens, there will be a load on power station throughout 24 hours it is required, whereas this portion and this portion, it will be, we can say that this one is peak load. It is because we can see here it will be required some around 6 megawatt. Okay, and whereas if I am, as I had drawn here, once again I will draw and I will show you here at 1 megawatt around, I will take a straight line, it required throughout a day. Okay, this is called base load and this is called peak load. Okay, one more graph I have here. You can see here, this is a base load where it is total, means the continuous throughout 24 hours it is required, hence it is called base load. And the peak load during which time it will be required, that is called peak load. I mean maximum load on power station is called the peak load. Okay, I defined here, sentences are there. Okay, base load is the minimum level of electricity demand required over a period of 24 hours, means throughout a day load is required, right? So minimum level of electricity demand over a period, whereas peak load is the time of high demand. Okay, as a in graph I have shown, the peak load is the time of high demand. This peaking demands are often for only shorter duration. If you are looking to this graph, you can come to know that. If you are come, I will show you that graph. Okay, so this is a shorter period here. You can see here. Okay, this is a shorter period of the time peak load will be existing, whereas the base is continuous throughout a day is required. I hope it is clear. This is a load curve. Load curve is drawn here with respect to time. It is drawn midnight to the midnight. It is drawn. Okay, midnight to the midnight it will be drawn. Say it is night, there will be 5 megawatt, after that 15 megawatt, 4 to 8 hours, then 20 megawatt during the 8 to 16 hours. Okay, the curve which shows the load variation with respect to time is called load curve. Okay, and load duration curve is plotted with respect to 0 hours to the 24 hours. It gives idea about how many hours will be the maximum, means the peak power is generated, and what duration, what hour, which it will be plotted from 8 to 12. If you are taking 4 hours, how many megawatt? 15 megawatt. If you are going and check here, the 4 hour, 8 to 12, 4 hour, it is 15. If you are check here, 4 to 8, 4 to 8, it is nothing but 4 hour. 4 hour is 15 megawatt. So here also 15 megawatt. And next, if you are calculating here the megawatt between 12 to 4 is 5 megawatt. Okay, 12 to 4 means how many? 4 hours. Okay, and next is 16 to 24. 16 to 24, how many hours? It is 8 hours, correct? 8 plus 4, 12 hours. All are getting here. Okay, 12 hours. So 12 hours, what load it is? It load is 5 megawatt. So if you are coming here in this load duration curve from 5 megawatt, it will be from 12 to 24. 12 to 24. 12 to 24, how many hours it becomes? It becomes 12 hours. Clear? Okay. With this, I conclude this session. Okay. Next, I will discuss about. I will go back and I will tell you what are the things I covered. Okay. I have covered in this session the quantity of water available. Okay, runoff river plants without pondage, runoff river plants with pondage, reservoir plants. This portion I have completed. Okay, next I will discuss high head, medium head, and low head plant. Next, third one is nature of load. The nature of load classified into based on the base load, peak load, and pumped storage plants for peak load. This points next video I will cover. Okay, thank you.